So here we are at Transformations Lesson 2, Part 2. And Part 2 begins by basically reviewing what we've learned so far for transformations. Remember, if k is positive when you're comparing to this equation or this equation, you will notice that you move up by a value of k. Here, if k was 6, it would be plus 6. Here, if k was 6, it would read y minus 6. Okay, if k is less than 0, moves down. H actually moves right and left, so if h is greater than 0, so if this read x minus 6, then h would be 6. So it moves to the positive direction by 6, moves right. H is less than 0, the graph moves to the left. Of course, if h happens to be 0, nothing happens. If k is 0, nothing happens. So there is 4 class examples to go over for this lesson. Write replacements for x and or y and describe how the graph of the second function compares to the graph of the first. Well, here are two functions, x to the 4, x to the 4 plus 3. What's happened is we've simply added 3. And notice that this is out with what's happening to x. X is being raised to the 4th exponent. So this actually refers to a vertical shift up by 3. You can also write it like this if you bring the 3 to the other side. So basically what's happening, notice what's happening to y. Directly y has changed to y minus 3. So that's the way to write it as far as replacement goes. If you were to replace the value of y in an equation, you would change y to y minus 3. Okay, so in that case, if you were doing it here, you would have to change this to y minus 3, which is this equation here, and we can rewrite this in the other way by bringing the 3 to the other side. Two equations here. What's really happened? It looks like x has been replaced with x minus 1. So we've affected the x value here, so it looks like x has changed to x minus 1. What have we done? That means we've shifted it to the positive direction by 1. Translation 1 unit right. Notice we've got the absolute value of x. Here, two things have happened. We've affected the x inside the function. We've actually negative 6 here, so that moves to the right by 6. And the positive 2 moves 2 units up. Replacement notation would mean that x has changed to x plus 6. Now, considering y, move this over to the other side, it becomes negative, so y would become y minus 2 using replacement notation. Here we have 1 over square root of x changing to 1 over square root of x plus 1. So x has been replaced with x plus 1. What does that mean? We're affecting the x value. Notice it is within something happening. This function is a square root. It's directly affecting the x, so we're moving horizontally to the left, to the negative direction by 1 unit. Last example 2. Write replacements for x and or y, and hence the equation, write the equation of the image of y equals x squared. This will change after a horizontal translation 3 units to the right. That's in the positive direction, so that means x will get replaced by x minus 3. So here we have the equation. B. Y equals 10 to the x. After a vertical translation, what does it look like if we move it, or a translation 2 units up? If we move it 2 up, that means we've affected the y in the following form. Y has become y minus 2. So we can write y minus 2 equals 10 of x, and then bring the 2 over to look like the following. C. The y equals square root of x. How does that change after a horizontal translation? 4 units to the left. So what happens there? If it's to the left, x is being replaced by x plus 4. And a vertical translation 3 units down. So you can't quite see it here. I'll just move this up. Actually, just let me write it right here. Y, whoops, pardon me. Replacement for y has gone to y plus 3. So we replace x with x plus 4, we replace y with y plus 3. This means it's gone 3 units down, as it's saying here. So we'll rewrite this equation. Y becomes y plus 3. This becomes the square root of x plus 4. Bringing the 3 to the other side, it looks like this. On the next page, example 3, the function represented by the thick line, that's this guy here, is a transformation of the function represented by the thin line. This has been translated to the new thick line. Write an equation for each function represented by the thick line. Well, what do we do there? We have to decide really what's happened to the thin line to get it to the thick line. And best thing to take is mark some points. So we definitely want to look at this point here, perhaps this point here, and maybe this point here, and see what has happened. Well, the vertex here is probably the best clue. Looks like it's gone 2 units this way, and 1, 2, 3, 4 units down. So positive 2 and negative 4. So in replacement in terminology, x, because it's moved right, x is replaced with x minus 2. And for vertical replacement terminology, y goes to y plus 4. So with this replacement technology, it does seem to do the opposite of what we'd expect. X is moving, the whole thing's moving to the positive direction, but we have negative 2 here. It's moving down in a negative direction, but we have plus 4 here. So keep that in mind when you're using replacement technology, terminology. Fair enough. The original was y equals absolute of x. So we replace x with x minus 2. And we replace y with y plus 4. So y becomes y plus 4, x becomes x minus 2. Bringing the 4 over, it can be written like this here. In the second part here, we can check the thin line and see what's happened. I would pick some points. This looks like a good point to observe, and perhaps this one here. So these 2 points, this seems to have moved. Kind of hard to draw. Maybe this is it here. I think this is the new point there. Looks like we've gone up 2 and over 1. Up 2 over 1. See if the same's happened here. Up 2 over 1 could well be. So up 2 and over 1. And that's what it says right here. Now if we go to the right by 1, x has been replaced with x minus 1. If we go up 2, y gets replaced with y minus 2. So we can take our original equation, which is y equals 1 over x, and that will become y minus 2. This will become x minus 1. So we have it here, and again we can bring this negative 2 over, it becomes positive. Well, you can probably work out what's going on in these two, and so this simply looks like this point has gone up by 4. This point gone up by 4. And it looks like this, all the rest of it's just a simple vertical shift up by 4. So y can get replaced, y equals f of x, y can get replaced with thin line to the thick line. So it's actually gone down by 4. Yeah, down by 4. Okay. So y gets replaced with y plus 4. So this is what it'll look like, and we can bring the 4 over to the other side, and we finally get this equation here. What's happened here? This point looks like it's getting moved up by that amount and over by that amount. So it's gone -3, it's gone left by 3, it's gone up by 4. So y will get replaced with, y will get replaced because it's gone up by 4 by y minus 4, and x gets replaced with x plus 3. So the original equation, y equals f of x, can be written like this, and 4 brought over to the other side, looking like this here. Well, the last class example, number 4, mentions that y equals the root of x. It's a radical function, and asks what vertical translation would be applied to this so that the translation image, the one we finally end up with, passes through 16.7. So what vertical translation would be applied to this so that the translation image will pass through that point? Well, we can look at it as if something's happened to y, so y has gone to y minus k as usual. So it's talking about only a vertical translation, not a horizontal. So we're only affecting y. So in that case, this original function will change to y minus k equals the root of x. That's going to be our new equation. It has this point in it. Well, these are values for x and y, and if this lies on this new equation, new function, then we can use 16 for x and 7 for y. Plugging them in, we can solve now. The only unknown here is k, so we can solve here for k. K ends up equaling 3. So we can simply write, instead of y goes to y minus k, we can simply write y goes to y minus 3. And so that tells us it's a vertical translation 3 units up. Now, what horizontal translation would be applied to the same function so that the translational image passes through 17.8? It's a horizontal translation, so it's affecting the x, right and left, so x is changed to x minus a certain value, h. Well, let's plug that into the original equation. So instead of y equals square root of x, y will equal the square root of x minus h. We're told it passes through 17.8, so these are valid numbers for x and y. X is 17, y is 8. Plug them in, and you solve for h. H is negative 47, so that means this should read x minus 47. So in other words, x plus 47 looks like it's a translation horizontally 47 units to the left in the negative direction. Okay, so for the assignment, there are 10 questions, and I would like you to complete all of those. Question 4, you could probably do the odds, but see how you're doing with that question. And otherwise, please do 1 to 10, and we'll see you in class.